Peace and greetings from throughout the boundless universes. Thank you this shadow hour or this day for joining us. All praise is due to the Most High. Thank you. We will be talking this shadow hour about some new mathematics. Thank you for joining us, Interef and Remy. Thank you for joining us. This shadow hour, as you can see from the write-up, we'll be talking about the origins of mathematics. But we'll also be talking about some of the flat earthers. Thank you, Miss Muhammad, for joining us. We'll be talking about some of the flat earth stuff. Basically a question somebody asked me on the internet about flat earth. And I apologize, y'all, I got a slight cold, but we're gonna try to get by that. I'm gonna pull up this post because I was gonna show the video first, but let me go on and show this post first of what this person wrote. And they just asked a simple question. It's a very good question, though. Very good question, because a lot of people confused about this question. Yeah, I see the brother Kim throwing some tonight at 10:30. Let me see right here. Let me see. Okay, I'm getting to it, y'all. I'm sorry about that. Let me go to this activity log. That's where I gotta go. It ain't on my post. So yeah, so I'm letting everybody get in here though. What's happening? Is that Ray? Yep. Musa Muhammad? Yep. Kenneth? Yep. Peace, family. Peace. Like I was telling the family, we about to get into a little bit of the flat earth just for a second. It shouldn't take long, but we got a while here. I just want to show you something. It was a question asked of me about flat earth. I'm trying to find, let me see. Okay. Every time, let me see now. Let's see here. Where is this post at? There was a brother that posted on I posted on his post about flat earth and about two dimensions, but he actually posted on my post. So let me see how it goes. Let me see. Okay. So but what we were talking about was flat earth in 2 dimensions and 3 dimensions. And I have a scientific statement that I make, you know? I have a specific scientific statement that I make regarding flat earth. Now, I don't know why I couldn't find that on my other phone, but I pulled it right up on my raggedy phone. That's usually how it goes. But this is my scientific statement, family. I usually say this right here. The earth is a 2-dimensional. Let's say it again. The earth is a 2-dimensional, smooth, flat surface of a 3-dimensional, round, curved sphere. Let's write that down. Let's get a pen right here. Let's write that down. The earth is a, let me move this heater, y'all. Keep that out the way. The earth is a 2-dimensional. This is really my scientific statement, but because I had to add the words smooth, flat to it, I have to look at it because of the simple fact that smooth and flat represent 2 different things. That's something we'll talk about this shadow of a three-dimensional round, curved, atmosphere. And then we continue that statement by saying, thus the earth is flat and curved at the same time. And I challenge myself with something, y'all. I write in all caps on the internet, and so then when I'm reading it in all caps, I have to remember not to write in all caps, to write in caps and lowercase on the board. So that's my own challenge to myself, is to be able to do things like that. Just like learning to write with both hands, or learning to write from right to left or from left to right. Let me see. So now this is our statement, family. Our statement is this right here. The earth is a two-dimensional. Now, what does two-dimensional mean? Do we need to look up the word two-dimensional? Do we? Okay, because two-dimensional means flat. Okay, because you have a point, you have the line, and then you have the angle, and then you actually have the tetrahedron. Not the triangle really, but the tetrahedron. The triangle is really a part of this. Okay? That's really a part of that. So now, so then the dot would be 0 dimension. The line would be 1 dimension. This would be 2 dimensions. And this would be 3 dimensions. Now, the line would just represent length. And this angle would just represent width. Now I want to show you something, family. This could just as well be this. Because an arc equals an angle. So don't be confused about this coming to a point. That's some of that crazy stuff. Look at this. The arc is equal to the angle. The circle is equal to the square. Okay? Those two are equal. So now, and this is a very important symbol. This is the bow of Sumer. This is the bow of ancient Egypt. This is the bow of ancient Africa, of the Pygmy people, of the Tahitians, the bow. So the length, the width, and then this one is length, width, and height. Okay? And I like to write this. I'm a linguist, so I like to write this. Height. So now, but this is the zeroth. This represents no dimension. But this ain't our point today. We done proved this point on many occasions to be new. But that's not really that much important right now. Other than we could talk about moving to the fourth dimension and move from 3, 2, 1 to the fourth dimension. We could talk about that. Okay? So, but the length, width, and height of things. That's the 3 dimensions. So this is the first dimension. This is 1 dimension. Don't let nobody fool you. I'm going to write it the simple way. I ain't going to write the word dimension out 3 times. I'm going to write out 1D. This is 1D. And this is 2D. And then this is 3D. Okay? So now, I can show on this board a dot. I can show on this board a line, 1D. I can show on this board a line and angles, 2D. But when it comes to showing 3D on the board, you have to be willing to suffer a hallucination and illusion to actually see that. Because there's really no height on this board. This board is flat. You see that? So then flat would equate to two dimensions, 2D and 1D. Now we could say 0D, but they don't know what 0D is, so we're not going to give that yet. Let's just talk about 2D and 1D. That's flat. This is mathematics, family. This is not an argument of, oh, the earth has hills and valleys and mountains and water on it. No, this is not that type of argument. This is a mathematical argument. This is mathematics. You see on my post, it reads, the pyramid mathematics proves that we knew the earth was round or a sphere or an orb and not a flat disc or a sheet of paper or a plate. So we knew that. So anything that's in 2D would be here and here. And then 3D is here. Now this 3D dimension, although it encompasses 1, 2, and 3. So this third dimension encompasses 1 dimension and 2 dimensions. That's what makes it 3. Because 1 dimension plus 2 dimensions equal 3 dimensions. Or else this 6th dimension, not to be confused. But 0 plus 1 plus 2 will equal 3. So then you have 3 dimensions here. So then I'm saying that if you say the earth is flat, then the earth would fall either in the 1D category or the 2D category. But either way, it would be 2-dimensional or 1-dimensional or no more than 2 dimensions. So then that would mean that this dimension, this 2D earth, or this flat earth that they discussed, let's get us an example of a flat earth. Because we know that nothing is truly flat. Greetings, peace, thank you. So then we put this on the board, the other shadow hour, to show that this will be what the flat earth would look like. See, that's a round object. That's a round object, but it has a projection of a circle this way. See that? But that's not how they say the flat earth is moving. They say the flat earth is not moving and that it's stationary and that it's flat this way. So then this projected shadow would be a straight line, straight across space. This projected shadow would be a straight line. So then this is what you would see on the moon. A straight line. That would be the shadow on the moon. It wouldn't be this. It wouldn't be a circle creating a what you would call a crescent. It would be a straight line going on the moon like that right there. That's what the earth shadow would look like on the moon right now. So we know that the earth is not flat just based on shadows, and we as Egyptians use shadows many a times. I done showed the shadow effect of the sun in its or in its many phase horizon, in its many phases, in its many phases. But we'll just show 9 here, but in its many phases. And we have shown the earth both curved and apparently flat on that plane with a stick, a tekken, an obelisk in the ground right there. And we have shown the light, how the light would shine over that tekken and actually hit the ground way out there. We done showed that. We done showed that if light hit from right here, it will have a less or more shallow angle. And as the light continues to hit this tekken, the lights will continuously have a less and shallow angle until you reach the point of the zenith where you get no shadow. So then there would be no shadow at 12 o'clock. And we even showed where if these were wells, if these were wells, right? If these were wells, then the light shining in these wells, the light shining down in these wells would be this way, right? Would be that way, right? But at a certain period of day, when the light is directly above this well, it would be no shadow by this well. It would be no shadows cast. It would be no shadows here because the light would be directly above the well. And if the light is directly above this well in another city, then it wouldn't be no light above that one. And therefore, we could triangulate. We could calculate from this city to this city up to this light down to that light. And we could triangulate. Or we could triangulate back the other way from that light over to this well, over to this city, and up to there. Either way, this will give us the differential in what this curve is on the earth. So this would show us that the earth is curved. Now, family, let's get back to the statement. The earth is a two-dimensional, smooth, flat surface. Now you hear that? This is my scientific statement. So the first thing I'm saying, that the earth is flat. The earth is a two-dimensional, smooth, flat surface. It is. That's what the surface of the earth is. The earth is smooth. Now, that's where our question come in at. Some people may say, as the person asked on the post I wrote this post, the earth is a two-dimensional flat surface on a three-dimensional round curved sphere. Thus, the earth is flat and curved at the same time. The earth is a two-dimensional, smooth, flat surface of a three-dimensional round curved sphere. Thus, the earth is flat and curved at the same time. One of my good friends wrote, well, you know, somebody from Facebook, they wrote, when you put it like that, you already know. And then Nuti asked, how is this the case when there are valleys and mountains underwater? Great question. How is this the case? How is the earth a two-dimensional, smooth, flat? Now, this is where you have to get in it. Surface. The only thing that's two-dimensional about the earth is that the surface is two-dimensional. The surface is smooth and flat. Nothing else other than the surface of the earth is two-dimensional. So the surface of the earth is a two-dimensional, smooth, flat surface of a three-dimensional. So now we get into the third dimension. So this is how we can have valleys and mountains, because the earth is also three-dimensional. Surface of a three-dimensional round curved sphere. So it's a surface. Now, any topologist gonna cuss me out for doing this. Anybody that's into mathematics gonna laugh when I try to show you this. But I don't care. It's the point that counts. Okay? Now, if we have a round surface, this is not round. This is not round. This is a icosahedron. But for all intents and purposes, so I don't have to go in the kitchen and get a pomegranate and leave the screen, we'll use this. If I try to cover this with this towel, now, even if I shrink wrap this to this surface, it'll never all fit, you know, because of the shape. No flat surface shape can actually cover a circle. Like you take a square, it can't cover it. You always gonna have some leftover. You have to cut. You're gonna have to manipulate. You're gonna have to work it in there. and it's still not going to completely cover it. You have to tape it together and paste it together and all type of stuff. It's not going to cover. So the point is that that's one of the unique things about the earth. That's how we know it's not flat. Because anything in this dimension, family, anything in this dimension has to be three-dimensional. It has to have a length, a width, and a height. No matter how thin it is. Even this napkin, they'll tell you this is 2-ply. I could stand here, and if I want to long enough, I could peel this napkin apart and have 40. Because this is 2-ply. It seems flat, it appears flat, but where's flat? Or how flat is flat? So then, when we say the earth is a 2-dimensional smooth flat surface of a 3-dimensional round curved sphere, thus the earth is flat and curved at the same time, we are simply saying that if you took this shape, this is going to confuse a lot of people because then they're going to think we're talking about domed earth. We're using this as a model. If you take this shape, you see that? It's smooth and it's flat, but it's still curved. It's smooth and it's flat, but it's still round. So don't let somebody get you caught up in a linguistic paradigm about what flat earth is. This should not turn into a linguistic argument. This should remain a mathematical argument and not try to turn it into, mathematics is a language in itself. So you shouldn't try to turn it into a dialectic, I should say, or a tongue or some type of babble. Because this is a 3-dimensional, not 1-dimensional, not just 2-dimensional, but 3-dimensional. 3-dimensional, smooth, flat, round, curved surface. See that? So this is the same thing the earth is. The earth is a 2-dimensional, smooth, flat surface of a 3-dimensional. This has length, it has width, it has length, it has width, it has height. See that? It has height off the plane. See? It's up. It cannot be put flat against the wall. Nope. It'll come off the wall like the Egyptians have the sun off the wall, indicating that the sun, the moon, and the earth are all 3-dimensional. See? When you put that on the wall, that's indicating something 3-dimensional. And if this is on the person's head, let me show you, family. See, this be the ridiculous stuff. This is what I'll be talking about. But if you put, there we go. I keep artifacts. If you put this on somebody's head, and then you show that and this is the same thing, and you put this on somebody's head, the person is 3D. So this has to be 3D. So the representation of the sun on the Egyptian's head is 3-dimensional. They don't have on a 3-dimensional body, and then when you look at the headdress, it turns into a 1 or 2 dimension. That's not how it works, family. That's not how it works. This is 3-dimensional. This is 3 dimensions of information. So you have to pull this off the wall and put this in the real world. This is not some 2-dimensional flat surface. You see, the people there are 3-dimensional. So then they can come off the wall. The statue is 3-dimensional. The sun on the statue head is 3-dimensional. So the Egyptians knew that the sun had a 3-dimensional. Okay? So now, and since we talk about the sun, yes, we can argue that the sun is 4th dimensional. We can argue that the sun is 4D. We can argue that the sun is 4D. Okay? So now, let me show you. So, we showed this the other shadow hour though, before I go on this. Let me see if I can do it in some type of way where it looks halfway decent. Nah, I really can't get no. Let me see. Good shadow. Nah, no good shadows on that one. So, but you get the picture that certain stuff like that, like this shape right here, this shape right here is three-dimensional. Now, if you had an Earth, this is about as flat as the Earth would get, and that's as elongated as the equator would get, and this is as flat as the Earth could possibly get. This is as flat as the Earth could get, because when we say flat, we're not talking about just flat like a sheet of paper. This is as flat as it could get in 3 dimensions. Anything flatter than this would become 2 dimensions, and that wouldn't be Earth. The Earth is 3-dimensional. So you can't say the Earth is flat because flat simply relates to 2 or 1 dimension. Okay? So now, thus the Earth is flat and curved at the same time. What we mean by that, I showed you. It's flat and curved at the same time. But what we also mean in the esoteric field is the circle equals the square. What we also mean is if you turn this square, it will turn a circle. So when you go around the circle, you go around the block. You see that? So if you turn this circle, this square, it will appear as a circle. So these are the facts of why we can say, even though the Earth has mountains and valleys underwater, that's because the Earth is 3-dimensional. Now, we could get into the gravitational argument with me only because we have the mathematics to prove that we have mastery over gravitational forces, that we have knowledge of gravitational forces and how gravity works. So we can actually get into the gravity argument with me and not just be stuck with Sir Isaac Newton left you or left people at. We can get into the mathematics of it and not just the way it works. But I heard a little small argument just to be quick. I heard somebody say, I think it was Curtis Koss on House of Consciousness TV, on Silent TV. He was talking about objects. And didn't nobody correct him. But somebody just should have told him that no matter how heavy an object is, it still falls at the same rate. It don't matter how heavy that object is. It will still fall at the same rate. So only thing that matters is if that object has what we call drag on it or something like that. If it's so light that the object has drag on it or something like that, then yeah, of course, the other object can fall faster. But it's the same thing. And then I hear some argument about some people saying, come on, family, it's simple physics now. If you hold up 2 objects, one of them could be heavy and one of them could be light. They're still going to fall at the same rate. Now, let me say something that may confuse you. The circle equals the square. So that means 360 or 361. We can go either one, but we'll go 360 for the sake of it. 360, because we don't have the dot in. 360 equals 360. Okay, so then that means 360 miles an hour. $360 miles an hour in a car is the same thing as 360 miles an hour in a boat. That means 360 pounds of rocks is the same thing as 360 pounds of rice. You get it, family? That 360 pounds of rocks is the same thing as 360 pounds of rice. A car going 360 miles an hour is the same thing as a boat going 360 miles per hour. 360 degrees equals 360 degrees. You see that? So no matter what it is, these are equal. It equals. It's something called equal to each other. So now, what I'm saying though, when it comes to gravity, this doesn't apply to everything. Because something could be lighter, let's say 50 pounds, and something could be 1,000 pounds. LB represents pound, family. So I don't want to be confusing though. Let's just write 1,000. Okay? So 50 pounds represent, 50 pounds and 1,000 pounds. If I drop 50 pounds and I drop 1,000 pounds, at the exact same time, they would hit the ground at the exact same time. They would touch the ground at the exact same time. 50 pounds and 1,000 pounds. It wouldn't matter which one. It wouldn't matter how heavy it was. So the gravitational forces work different than the forces that's related to speed, that's related to mass and density and weight. They work different than these forces because no matter what you put over here, it's going to fall at the same rate. Now, the opposite is not true. The opposite is not true. It would take more energy to lift something 1,000 pounds than it would to lift something 50 pounds. You see that? So this right here tells you there's something in between gravity that can be grabbed. In between gravity that can be grabbed, and that's something that's in between gravity that can be grabbed is called buoyancy. And you see this a lot, but this because, family, I have to tell the truth. I personally introduced the word buoyancy in relationship to gravity to the scientific world. And so then buoyancy. And this leads us to levity. And that's why on the same video, when they discuss a boat traveling on water, look how heavy a boat could be. Look how heavy a boat could be. A ship can weigh 10 million tons, and it can still float on the ocean. And you could take a rock and throw it in the ocean and it'll sink straight to the bottom. Why is that? Why is it that I could float a ship on the water and I could throw a rock in there and it'll sink? I could throw a car in there, it'll sink. But I could throw a boat in there and it'll float. So obviously, 1 second, family. Obviously, gravity has nothing to do with that. Come on in, Mom. No. I'm doing the live stream. How you doing? How was your day?
I'm good.
Good? You look beautiful.
Wait. Is my mom's charger here?
Thank you. Just daughter coming in. What you need, Iris? Anything? Oh,
No,
okay. So yeah, so the Earth is a two-dimensional, smooth, flat surface of a three-dimensional round curved sphere. Thus, the Earth is flat and curved at the same time. We are proving here that these are the dimensions of the Earth, 3 dimensions, not just 2. We are proving that something round, something curved, or something arced, and something angled are the same. We proven that something curved and something angled is the same. Now, this is important, family, because I'm getting at something. If the arc is equal to the angle, archangel, the arc is equal to the angle, then that means you could be on something curved and think it's square. You could be on something square and think it's curved. So you could be going around the corner or be going around a curve, and you will know the difference. What's the difference between a corner and a curve on the street? Exactly. Nothing. The arc equals the angle. So when we get over here, get down here to a speed, we see that these are equal in speeds, in degrees, in several magnitudes, on several levels. We can make these equal. Like we make these equal. But at a certain point, these become unequal. We can show that. Gravity, buoyancy, and levity. You can have something 50 pounds and drop it, and 1,000 pounds and drop it. They'll drop at the same rate. You can have something 50 pounds and throw it up in the air with your strength. You can have something 1,000 pounds and can't even lift it off the ground. So there's something happening between gravity with weight and density and mass. And that's something I'm telling you is buoyancy. And this buoyancy relates to levity. And once you learn that everything turns a circle, what goes up will come down and vice versa, then in order to get something up, in order to get it back down, that's dealing with something called the shifting of weight. The shifting of weight. That's how the pyramids was built. The shifting of weights. So that's how one will overcome gravity, by way of something called the shifting of weights. And that's on this earth plane. That's how one would overcome gravity. It's several different forms of gravity. Gravity can manifest from electromagnetism or centrifugal and centripetal forces. Gravity can manifest from several different levels. You can have a gravitational field. Just like you can create magnets by way of light at a light at an angle of 19.5 degrees, angle of arc, angle and speed, can magnetize rock. That rock can become a magnet. Or you can take something metal and you can magnetize it by sending an electric current through it via a battery or something. So that's magnetism. So you can create gravity and magnetism several ways, family. It's not like one way that gravity exists. It's not like one thing that creates gravity. No, gravity is a constant in this universe. Okay? It's one of the four forces of the universe. So when you have a force like gravity working on something like the earth, but now, family, let me see. I have here a dodecahedron. Love it. So now, I actually like the icosahedron better, but they have little bitty triangles. For some reason, they make these big. I know why, because it's the 5-pointed star. Okay, so when you take this gravity, let's pretend this is the Earth. Let's pretend this is round. This is a good example. Now, when you take the Earth and you take its flat surfaces, smooth, flat surfaces, but still is round, still is an orb, still is curved, still is the whole Earth. So it has an inner and an outer. It's three-dimensional. When you take that, okay, now this goes into sort of like Einstein's theory of relativity. If you put something on this, like this marker, and I drop this, if I drop this thing right now with this marker sitting on top, right? If I drop this with the marker sitting on top, the marker will be weightless on the way down to the ground. The marker will weigh nothing on this. It's just like being in the elevator. If I put it in there and I put it in the elevator, and then the elevator drops, the people in the elevator are weightless in the elevator because the elevator is falling. So then the people in the elevator, they weigh nothing in the elevator. You see that? They become weightless in the elevator because their weight is absorbed by the fall. Their weight is absorbed into the crushing. You see that? So it's no, how can I put it? It's no force. It's no force that's making us float or making us be separate than the things that we're attached to on earth. So what I'm getting at, family, is that when you have something like an earth and you take it and you look at it and you realize that it's three-dimensional, then you realize it has a center. And if it has a center, then it has a center mass. And if it has a center mass, then it has a density. And if it has a density and a center mass, then it has a gravitational pull and effect. And if it has a gravitational pull and a gravitational effect, then everything will be pulled toward the center. Everything on the surface, let's prove this point. Everything on the surface will be pulled toward the center. So that means all of the heavy water. So now, just like it is, it's not hard to lift a 50 pounds and throw it up. It's hard to lift 1,000 pounds and throw it up. Now, can somebody tell me how much the waters of the planet Earth weigh? The planet Earth itself weighs 6 sextillion tons. 6 sextillion tons. So we'll say that the water is 3/4 and the Earth is 1/4. We'll give them that, which we know is 72.2%, but we'll give them that. It's the same thing as the room temperature, 72 degrees. So it's the same thing, 72.2, with this ratio of the Earth and the water, and the same thing with the body. The waters in the body is 72.2 or 72. 72 divides 360 evenly, not 70, or 75 is not 70. It's 72. That's the pH balance, 7.2 in the body. So this is what we're talking about. So when you take this and you realize it has a center mass, it has a gravity, it has a gravitational effect or pull, and you take something as heavy as the water, and we have 6 sextillion tons. So then we said we want to divide that into we want to divide that 6 into what? We want to divide that 6 into 4 equal parts because we got 72%. So then if we divide 6 by 4, okay, that'll give you your answer of the ratio of the Earth's makeup, 6 sextillion tons divided by 4. So divide 6 by 4, and that'll be your answer. Let's do that right quick. 6 divided by 4 equals 1.5. Okay? So then, that's how much of the Earth is land. 1.5. And the other percent is going to be water. So now, how much does the water weigh? We know. The water is so heavy, the water creates its own gravitational effect and own gravitational pull. So it's locked down to the Earth by its own weight and own density. One more time, family. It's that time when everybody comes home. Hey, my love. How you doing? I'm doing a live stream. Come on, get there. Come on in.
Oh, you're doing a live stream?
Oh,
Yeah. I'm tired of interrupting.
No.
I bought this one. Okay.
No, you ain't interrupting.
I gotta take the keys. I'm gonna go back to the vehicle for the thing.
Okay, you want to tell me about it? Come on, please.
I look horrible.
Yeah, you look
How
beautiful.
I'm tired. Hey,
Rahul back.
Rahul back.
Greetings.
Greetings. heat
Yeah.
from throughout the boundless universe. I
That's
just
right.
got home. It's cold outside. I hope y'all enjoying your session.
Yeah.
Yeah?
Yeah. We're doing good.
Okay.
We're doing good.
Great.
We are going slow. This shadow hour kind of slow and kind of being repetitive because we had a lot of interruptions. But not only that, I'm glad. I wanted to go slow because I want the family to see what I'm saying. Like, this is a lot of intricate things. This is a lot of arguments by the flat earthers. And so right now, I was just showing them about gravity, buoyancy, and levity. And I hope they didn't lose me on that. That the weight's on this, and that things are harder to lift if they're heavier. And so the waters of the earth are really heavy, so they're harder to lift. Whereas things like birds can fly. So you'll hear a flat earther say, if gravity's so strong, how come it can hold all this water down and yet a little bird can fly? That's exactly the argument. That's exactly what we said. That gravity is so heavy. And actually, gravity is considered the weak force. One of the weak forces and not a strong force. But anyway, it's so heavy that it does not allow the water to fly because the water is so heavy. But if the lighter thing is, it will allow it to fly. And that's for the same reason if I drop 1,000-pound rock or I drop a 1-pound feather. Now, if I drop a 1 gram feather and 1,000-pound rock, the 1,000-pound rock is going to hit the ground. But due to the drag, the 1,000-pound feather is going to float. That's our key word, float. See, float, gravity, buoyancy, levity, float, vortex, air. Vortex can be water or air or space. Vortex can be water, or gravity can be water or air or space. Buoyancy can be water or air or space. Levity can be water or air or space. You see that? So, family, you have to be able to see this. You have to be able to see that a thing can be water, air, or space. And then you can even add in energy in here. You can add in matter. You can add in energy in the floating. Gravity can be water, air, space, or energy. Buoyancy can be water, air, space, or energy. Levity can be water, air, space, or energy. So all those could be water, space, air, or energy. They can operate in any field. So that's what makes gravity a universal constant force, but yet it's a weak force. But yet, the bigger they are, the harder they fall. So the bigger they are, the more they recognized by gravity. The bigger it is, the more it's recognized by gravity. And so the more effect gravity has on it. And the lighter it is, the less recognized it is by gravity. And therefore, light particles can escape the gravitational field. And like they say, everything can be sucked into a black hole. No, it's particles that's light enough that can pass right over black holes. That's right. It's particles that's light enough that can pass over what you call a black hole. Now, I want to be clear, family, because I'm sort of being ridiculous here. So I'm going to make this a stop, because a black hole is a collapsed star. And you'll see that as an ancient symbol in ancient places. And you sometimes think it's other stuff. This is a collapsed star. This is a black hole. A black hole is a collapsed star. So it's particles that's light enough that can pass over this black hole without being affected by it. They light enough to be passed over this black hole. And we have identified those particles by using this number nu and 0. And by adding these number lines together, we have come up with those numbers. And we know the particles that can levitate above the gravitational field of a black hole. Okay? So this is what we're talking about. So when we talk about a black hole, we're talking about a collapsed star. When we talk about a rabbit hole, we're talking about, oh, let's do it over here. Great place, great place. When we're talking about a rabbit hole, we're talking about dimension. We're talking about a warp. We're talking about dimension. Okay? We ain't talking about moving through no hole or going around a circle. going up and down or going around a circle. No, we're talking about moving interdimensionally between space and time. When we say like moving from 1D to 2D into 3D, popping into 3D and pop out of 3D into 4D and back and forth. That's what we're talking about. So a rabbit hole is dimensions and a black hole is a collapsed star. They're so dense and so heavy with mass that it draws anything else with density and mass towards it. But those things that's lighter than density, that's lighter than mass, can exist. Those are particles that actually exist in and throughout a black hole. So those particles have never been described to the world before, and now they're being described to you. Particles that's lighter and lighter than any other particles that can actually pass through or pass over a black hole and not be affected by a black hole. And those are called interdimensional particles. I repeat, those are called interdimensional particles. So now, so on the flat earth, so we see how water and things are held to the earth now. And we see how they glued to the earth now. Because it's a particle that actually works called the graviton and a gluon that actually glues heavy particles together. This can be seen in crystals. And the way crystals form is by pressure of the earth. The way diamonds form is by pressure of the earth. So by the pressure of the earth, the heaviness, the density, and the mass of the earth being compressed into a single area, it produces where those particles get lumped together and the other particles get pushed out, and those particles that were stable enough to stay together, called graphite or graphene, those become diamonds. That carbon becomes diamond. You see that? And so that's what gravity is. And so that's how things glue on or come together, like tachyons. And these particles are the particles that's actually holding the earth together. They're called tetrahedral forces. These are the four forces that's actually holding this thing together that you call earth. So one could argue that the earth is a tetrahedron because the forces that's over the atmosphere are these four forces right here, and not necessarily your orbital or your spherical forces. There are forces. Remember, the circle or the orb was placed inside the box. So this would be what the orb would be in, and this is what the center of the earth would be. You know, hollow earth, the central earth is the sun, but I'm saying that this is the center of the earth. This is what the sun would be shaped like. This is what would be turning. As above, so below. So that's how a person can have mountains and valleys on the earth and still the earth be round and not flat. You see, because the argument could be, if the earth, let me show you something, family. Let's erase our statement now. I think everybody got it. This is part of the reason why I asked, how flat is flat? This is why we ask the question, how flat is flat? Because flat earthers have a way of making a statement. Okay, if the earth is flat, how can we have hills and valleys? Case closed, ain't it, family? If the earth is flat, how can we have hills and valleys? If the earth is flat, how can we have hills, valleys, and underwater? Now, if the earth is beyond flat, which is one dimension or two dimensions, then if the earth is some other shape, any of the other shapes, be it tetrahedral, peace, thank you, family, tetrahedral, be it hexahedral, be it octahedral, be it dodecahedral, or be it icosahedral. It doesn't matter. Or be it a rock. it's still, right? You feel me? It's still the same thing. It's still three-dimensional. So a three-dimensional surface, let's get this right, family. Okay, let's get this right now. So now, let's make the earth three-dimensional instead of a flat. Let's make it three-dimensional. Now, first you gotta look with me, family. You gotta look with me. I want you to think back to this. Think back to this. Think back to when you see this is three-dimensional. Okay? Think back to that. Now, so the same way this is three dimensions, thank you, family. Thank you for the love. Same way that's three-dimensional, it's the same way this is three-dimensional. See that? And remember now that the arc is equal to the angle. So just remember that this is equal to this. And this is equal to this. And this is equal to this. See that? So these are equal. Just like this is equal. If I turn this around fast enough, it'll cut a hole in space. And the hole that it'll cut in space will be a circle. It'll wind out a circle no matter which way I turn it. So now, once we realize our flat surface can be three-dimensional, now we can talk. Now we can talk instead of just looking at this as two-dimensional. We can also show so we can show something like this. You know? Now, that may look to you from one angle a cylinder. But don't think cylinder. Think three-dimensional. Think this. Think this. Think that. See that? Think that. Because that's the same thing. Now think that. This is what the ancients did. This is why we had those symbols. These symbols represent three-dimensional thoughts and ideas. They do not represent two-dimensional thoughts and ideas. They're not mandalas. They're not hexagons and hexagrams. No, they're more than that. They're hedral, meaning they three-dimensional. Okay? So think that. So now, you have the earth that is three-dimensional. You have an earth that is three-dimensional. Now, so you have a place where you can put things in, right? Now look, the reason why I showed you this is because this forms what they call a Mobius strip. You see how this is the hot, and you see how it turns itself inside out? See that? So if we had a light, we could show that. If we had the right type of arrow, we could show that kind of topology. So with that type of experience happening on the planet Earth, you can have a central sun or a central place of gravity, a center of mass. You can have actual crevices in here. The pyramids prove this. Same reason why you got a king's chamber and a queen's chamber in a big, massive structure. You have hollows in a big, massive structure, yet the structure is still stable. And they base the pyramids off the symmetry of the earth. So they're showing you something. The subterranean chambers are actually the subterranean chambers of the earth. The earth is actually hollow, not flat. And they're trying to take you away from where you're supposed to be going. Better go learn. Now check it. So you got these chambers, these hollow chambers. And then here, between the surface and the crust, you have waters that go all the way down into the earth. And they rise up to the surface of the earth, these waters. And they cover vast portions of the surface of the earth. Now that wouldn't be possible for those waters to cover vast surfaces unless they were sitting inside of something. The water has to be sitting inside of something. So then the water is actually sitting inside of the earth. And the water fills up whatever it fills up the portions of the earth that it's in, and then it rises and seeks its own level. So you can't measure a lake or an ocean or a sea and say that I measured that and found that the earth was flat, when all water seeks its level anyway. So that won't show you a curvature when water seeks its own level. So first of all, 3/4 of the earth cannot even be measured to be not called flat. 3/4 of the earth would be flat because 3/4 of the earth is water. Fact. So now, but that still does not mean that the earth is not three-dimensional. When I say the earth, 3/4 of the earth is flat, I mean it's no flatter, it's no less flat than the inside of this cup. The inside of this new bowl, new mathematics, new bowl, the inside of this new bowl is what? Flat. So then water can sit inside of a flat surface. But when we say inside, we have to add depth or height, which adds the third dimension. Because as we showed so eloquently on our last math session, where's my thing? We have flat earth. We have water. Let's pour water on a flat earth. And that's what we get, a floor full of water. See that? We get a floor full of water. We can't fit water on a flat surface. See that? Hello? Will you bring some water, please? I just poured my water out. Drinking water? Yeah. I got my cup right here. So, yes. I was working on doing a demonstration. Okay, so anyway, so this is how Earth works. So you have a globe, and then you have an inner part to the globe, and then you have water resting in the globe, and thus water seeks its level on the surface of the Earth. Thank you. So now, so we will get back into this though. Maybe not this shadow hour, but I got a video I want to show y'all called Higher Dimensions, where we actually gonna blow, we're gonna blow the flat earth thing out the water. We just really taking it slow on the indigenous side. We haven't really gotten into some of the other arguments that we have. I just want to show by way of indigenous aesthetic mathematics and linguistics that we had already figured this out. We had already figured out the earth was round. We had already figured out that the earth could not be flat because you cannot hold water on that. Flat earth does not hold water. You heard that saying? Pun intended. The flat earth does not hold water. That won't hold water. Water leak off the side of that like that. I don't care how many polar ice caps you got. I don't care. And it can't be a polar ice cap. When they say the North Pole is right here on flat Earth, but then they say it's an ice ring going around the Earth. So then you tell me it's cold here, and cold here. That's ridiculous. And then you tell me that the sun is here and that the moon is here. That's what you tell me? And then you tell me, well, let's make the moon lower. Okay, you tell me the moon's here, and then you tell me this is the flat Earth. So how can a flat line project a round shadow? A flat line cannot project a round shadow on the moon. Okay? So then they say this the North Pole. They say this the North, the Arctic. And then they say this the ring, the circle. So now, and then they say, so then this becomes a yin yang. This becomes a yin yang, and the sun and the moon interchange in a yin yang pattern. They go around each other like this. Right? Now, this don't make sense because we don't see that naturally in the sky. But not only that, family, if you had this mix right here going on, at a certain point, the sun and the moon would be right here opposite each other. And at a certain point, see, it looked like it's night over here now. No, it looked like it's night, looked like it's shadows. It looked like it's light over here. It looked like something is working out because you got that going. But you have to see these two in motion in 3D. Once we put them in motion and we see that the fields cross, that the light crosses with the moon and the moon crosses with the sun, and that the moon will actually block the sun right here. The moon would be blocking the sun right here. So then this would be called an eclipse. So then that would mean you would only get an eclipse on this part of the earth. It wouldn't be no eclipse out here. And then when the sun was here and the moon is here, then at that point, you would get total sunlight without the moon being in place in front of the earth. You would get total sun from the sun. And that would mean this whole thing would be lit up. These are lies. You wouldn't even have a nighttime. At the point when the sun went around here and came right here, you would have total sunlight. And that would mean that you wouldn't have a night or a day here. It wouldn't be no night or a light here. This would be all just light. And when the moon was right here, it would just be all night. And then right here would be a period of time where it's all light. And right here be all night. And then over here would be all night. And over here would be all day. That wouldn't make sense, family. You would have this mixed up session, this great area of a space where these people wouldn't experience no time. And that's explained up here where you take the polar position of the earth. You take the natural pole of the earth. That's the natural pole. And then you take the magnetic pole because the earth is tilted on the 23-degree axis. So then you take the magnetic pole. And then this makes sense because the earth is tilted away from the sun. The earth is actually tilted away from the sun. And part of that is due to the sun's pressure, the pressure of the light pushing against the earth, causing the earth to actually spin, which causes the earth to actually rotate. Something else you never heard about in science. These solar winds, solar flares, solar light, this cosmic energy pushing on the earth causes a ball in water, like a ball in water floating. It's going to start to turn and spin and float around the water one way or the other. So, and that's based on which way the light hits the ball in the water. The light hits the ball on this side like a cue stick. Like if you play pool, you might know what I'm talking about. And on right hand, I shoot pool left hand. So if you shoot pool, you will know what I'm talking about. You will know that this is like your cue stick. This is like your actual cue stick. And this is the angles you playing on the table. These the angles you playing on the table. This is your cue stick, but this the angle you playing. You got to compensate for this angle. So when you hit this ball, when light hits this ball, it compensates for an angle. And the ball begins to turn, rotate. It rotates. But not only does it rotate, it begins to revolve and rotate due to the pressure of the light from the sun. Now, you may say, why doesn't that float off into space? Because this same pressure that causes it to spin and causes it to go around is the same thing that pulls it back. Because this thing has a lot of mass, and because this has mass, it has a gravitational pull. So it's called a light push and gravitational pull. Light pushes, gravitational pull. And that light pushing and gravitational pull is none other than flotation, gravitation, buoyancy, and levitation. That's what we're talking about here, family. So the earth can have water on it and be a round sphere and hold water. And then people can walk on the earth, family. It's not like you standing right here on the earth's surface. You're exactly right, people. It's not like you standing right there on the earth's surface. No, everybody is in the earth. Everybody here is in the earth. Even in the scriptures, it describes you as being in the earth. It doesn't say you on the earth. It tells you was in the earth, cast down in the earth. Okay? So now, you in the earth, so then that means that you below sea level. You below the mountain, you in the valley. Okay? You're not on the surface of the planet Earth. Okay? So now, you're here. Now, compensate for that. Because if this is the surface, then this is the inner earth. So you're here, not here. And I'm asking you to see this in 3 dimensions, not with a wire brain. Don't see it with a wire brain. Don't see it with this kind of brain. See it with this kind of brain, with a bird brain, a bird's eye view. Take a bird brain and a bird's eye view and see it, not a wire brain. Okay? So those are the things that I want to tell y'all, family, about just overstanding and the things that you should play in your mind about flat earth. These are the things you have to play back and play through your mind and understand these things and say, hey, I have to gather concrete mathematical evidence, not pictures, not words of people, not lots of fancy people talking, but actual mathematical facts. And I have to pull it out, family, every time. We have to pull it out because it's part of my mathematics, okay? So it's just a part of what I have to do. I know my job and I know what I have to do. Some people may not understand it or understand it, but those who do, thank you for understanding what I do and why I do it this way. So I have to show this. That when we're talking about that circle, once again, it leads us back to this paper. When we're talking about that circle, it's going to lead us back to this paper. Okay, family? It's going to lead us back to this all praises due to the Most High paper. This proof of circle in the square. Or proof of the circle or square. It's going to lead us back to this paper, family, because this paper is the mathematical proof of a lot of different things, a lot of strange things, as to why we use the hexadecimal or hexadecimal system. It's proof as to why we use 360. It's proof. It's proof of the circle, proof of the number 0, proof of the numbers nu and on. It's just a lot of proof here. It's just a lot of things going on here, family. So I just want to keep showing this to you because this is me showing mathematical proof of my knowledge of the earth and its shape and its texture. This is not me feeding you a bunch of conjecture and telling you to go check out NASA or go read a website. You haven't heard me refer to one single website. I don't have to because I can measure the earth for myself. I can see it with my own eyes. I got my own brain. I can use my own heart and my own mouth to express this. I don't need nobody to show me that. I can look at the earth and see that. I can go walk out there and do a scientific experiment for myself. I could put a stick in my mama yard and a stick in my grandma yard in another country. And I could call my grandma and say, Grandma, when it's 12 o'clock here, I'm going to call you. Okay? It's going to be 9 o'clock there, Grandma. When I call you, pick up the phone, Grandma, and tell me what the shadow looked like in the morning at 9 o'clock in the morning. It's gonna be 12 here. I ain't gonna have no shadows, Grandma. Tell me if you see shadows. If you see shadows, Grandma, it's a problem. It means the earth is curved in some way. Now, Grandma, I know you live west of here. So then I can look back west from where I am east, Grandma, and tell you what distance you are from me, Grandma, based on the shadow, based on the length of the shadow that you measure in the yard, Grandma. When you measure the shadow in the yard, tell me how long it is. Give me a kiss, my love. Where you go? I'm acting like a baby.
I'll be back. I'm gonna go get some onions and garlic. So,
okay, what you making tonight?
I think I'm gonna make some white rice with like vegan ground meat.
Okay.
And some spinach and tomatoes and some plantains.
Sounds good.
Yeah.
I'll be ready.
I love you.
I love you too, babe. Hurry back.
Yeah.
Be safe.
Thank you. Yeah.
Let me see. So now, so yeah. So the point of this is to show that I have the facts to back it up. Like you have to take this paper and then just show me where it's wrong. Do that and I'm good. I'm good money on the flat earth and everything. Do that. Just take this paper. Just take this paper and show me where it's wrong. And that's a mathematical question. That's not no argument. Ain't nothing to talk about. You pull out your pencil and your paper and make one. And prove to me that the earth flat. Because according to this mathematics, the earth is a sphere. Okay? So what else can we talk about? So family, I said that, and I can't really see this thing. I just clicked it anyway. I hit it anyway. Let's see. It reads, we will first answer a question flat earthers asked about valleys and mountains. I think we whipped that question. I think we beat it to death. I think we showed dimensions. I think we showed weights and gravity. I think we showed a mastery of gravity, levity, buoyancy, and flotation. I think we showed you a rabbit hole interdimensionally. I think we showed you a black hole, a collapsed star. We showed you particles that can overcome that can float, that can actually levitate above and come up out of a black hole. We showed you those particles. We even showed you some glimpse of the mathematics that's involved in creating those particles and the things that's involved in creating those particles. And we show you here the round earth in a good way, in a way that you can see in a Mobius type way, where you can see in and out the earth, the surface and the crust. And then we show you the earth and the sun and its directions and what we held as sacred symbols, as three-dimensional symbols. And we show you how the flat earth could never work, how the sun and moon interaction would never work, how the whole earth thing right here would never work. Flat earth would never work because you can't hold water on a flat earth. It's only two-dimensional, and we are ourselves three-dimensional beings. So what you would be saying is, in effect, that we three-dimensional beings are living on a two-dimensional surface. That means, where do plants come from then? Because plants are three-dimensional. So you telling me that plants are grown on a two-dimensional surface? No, they're not. We put plants in the ground. We put seeds in the ground, and those seeds are three-dimensional when we put them in the ground. And they grow up from the ground three-dimensional as three-dimensional flowers and bloom as herbs. So these stories, thank you, fam. So these stories and these things that you're talking about, flat earthers, are ridiculous. And no, I'm not a globalist. I'm an indigenous aesthetic mathematician and linguist, a linguistician, as I say, as we say. That's what I am. I'm not a globalist. I'm not a flat earth. I know that the earth is hollow. I know that the earth is round. I know that the earth is not flat. And I know that the earth has a dome. I agree with the dome earth. I agree with the dome earth, meaning it's a dome over the earth. But it does not mean that we live on a flat surface here with a dome over us. No, that's fictitious. That's not real. Okay. So I did say in the post though, I wrote We will reveal and explain the foundations and fundamentals of all indigenous aesthetics, mathematics, and linguistics is of Egyptian, African, Nilotic origin, known as Ma'at. And I left out the AKA Ma'at mathematics. Okay? So then, how about we do that now? How about we reveal and explain the foundations and fundamentals of all indigenous aesthetic, mathematics, and linguistics, being of Egyptian, African, Nilotic origin, known as Ma'at or mathematics. You will be reminded of your higher being during this. You'll be reminded of your higher senses and your higher intellect in order, Ma'at, for you to return to your higher state. This is what this segment is about. Now, I'm going to put up a video. We can put away the regular phone now because I couldn't pull up Facebook on this phone for some reason. And now Facebook is up, but that don't matter. We're going to YouTube. Let's see if YouTube will come up for us fast. So let's see. Okay.
Numbers.
Okay, we got to go. Well, guess what, y'all? Can I have 1 second break? Look, my water is empty. Let me get some water. Y'all know I got to rest with water. I just brought the jug can. That's cool. Okay. Let's get this internet thing pulled up. Come on, man.
Where did these numbers actually? Yes, mathematics is all about numbers. But where did these numbers actually came from? Who got these numbers? Who introduced these numbers? What is the history of these numbers? Let us see. Well, even the Stone Age people had some concept of number, though their number system was way limited than our number system. So let me take you back to...
Okay, family, before we move forward, I do have to put in a disclaimer. Now, I put some bubble gum in my mouth because y'all was doing that. But listen, it can't go like that. We have to be more intelligent than this now. This is not my viewpoint. This is her viewpoint. But the gist of it going to be good. But just in the beginning, I want y'all to research things like the Ishungo bone, the Limbobo bone. Research these things and, you know, the pygmies, the ancient Tahites. Look these people up because these people predate what you call cavemen. And what she's saying is that we actually started out in a cold climate as cavemen, and then we came into, you know, some form of knowledge. She's going to jump from the cavemen to the Egyptian. That'll tell you enough. She jumps from the caveman to the Egyptian. So we know it started in Africa with the pygmies and with all of our people on up the Grimaldis, on up the Deneg, on up. And so this is who we are, the Tahites, okay? So disregard this little tiny part where she talk about the caveman. But it is important because she's going to mention 30 symbols. And you can actually look up on the internet, look up 60 symbols. They do math shows, and they'll tell you different things about mathematics, but this 30 plus 30 equals 60. And the 30 is half of 60. And remember, your base system was base 60. So let's get going. So you originally had a base 60, base 12, base 10, base 9 system.
Stone Age now, and let's go through this journey of numbers. But remember one thing, that in this time period, people know nothing about numbers. So it was fairly easy back then.
They knew nothing about numbers.
They didn't have any need to know exact numbers, nor did it matter exactly how many animals were there or how far. All that mattered was that there were some animals near or far. they would hunt those animals and go that distance without any need of knowing exact numbers. Later they realized that they could not communicate or tell the other person exactly how many animals were there. And so they realized that they would need numbers. It is said that they probably started counting by fingers. But since they had just 10 fingers, they could not count beyond the number 10 using fingers. So for larger numbers, they started using tally marks. However, that too wasn't sufficient for large numbers. So they started using stones or pebbles to represent numbers. This too was always not possible. Early man was still far away from numbers, but at least now they could understand by looking at a pile of stones that larger the pile, more the number of animals. Centuries later, we moved on to a civilization where people not just hunted animals, but they started domesticating animals. From caves, they moved to huts. Barter system was started. People started interacting and exchanging things. Now, for the exchange of things, they had realized the need of exact numbers. So they invented these 30 numbers. These are the first 30 numbers that they used. One was called Tim, Sim, Pim, Flop, Bam, Ram, Slop, Clop, Fam, Amba, Samba, Jolo, Polo, Molo, and so on. So they kept on numbering and naming these different symbols. They gave each
Look at the symbols, fam.
They called number 29 as Maya and 30 was called as Zaka.
29 is Maya.
Meant a whole lot of numbers. So
Maya.
was a whole lot of numbers. There were a lot of problems with this number system. Though they had come up with 30 symbols and names, but it was extremely difficult to memorize them. Not just this, mathematics was becoming really difficult. For instance, if you had Bam cows and someone took away Tim cows from you, then you would be left with Plop cows. Now it would take so many years for anyone to memorize all the different combinations of these 30 symbols. Centuries later.
So that's why she said it wasn't really mathematics, is because they were just counting in a pattern. They really wasn't using the numbers. They would remember the different combinations of what would be subtracted and what would be added. So they would have a visual or a mental understanding of 30 combinations of that. But they really didn't have a system of numbers, is what she's saying. And this would be a lie. The pygmies, as like I said, researched the Ishango and the Limbobo bone, and you'll see that we had knowledge of not only math, but prime numbers, as well as using it as a calendar and using it to count menstrual cycles and everything else, days of the week and everything else. But of course, like I said, this video is based around their knowledge. So let's get it popping though, because from here on out, the video is going to be very interesting.
Come up with 30 symbols and names, but it was extremely difficult. Extremely difficult to memorize them. Not just this, mathematics was becoming really difficult. For instance, if you had Bam cows and someone took away 10 cows from you, then you would be left with plop cows. Now, it would take so many years for anyone to memorize all the different combinations of these 30 symbols. Centuries later, Egyptians came. Egyptians had varied interests. They were extremely fascinated with numbers. They constructed tall pyramids and were also interested in astronomy. For all this, they had invented large numbers. Let us take a look at the Egyptian number system now. They used objects from everyday life as symbols. A rod stood for 1. They used 2 rods to show 2. Similarly, 3 to show the number 3, and so on till 9. They realized that using 10 rods for 10 was getting too long, so instead they used a horseshoe to represent 10. So a horseshoe represented 10. They would use 2 such horseshoe to represent 20, and so on. So 9 horseshoe would represent the number 90.
Beautiful, ain't it?
They realized that using 10 horseshoe to represent the number 100 would be too long. So instead, for 100, they used the symbol of a coiled rope. Egyptians made a symbol for every power of 10. They used a lotus for 1000. For 10,000, they used a pointing finger. For a lakh, they used a tadpole. And an astonished man was used to represent 10 lakhs.
Okay, I want to show you something right quick, Tony.
They used objects from everyday life as symbols. A rod stood for 1. They used 2.
1 second, family. I had to go get a fresh thing of these. Clean the board off. Okay. Okay. I just want to show you this, family. When she said 1, Okay? So if we go across there, first of all, family, this is not a horseshoe. This is a rope. This is not a horseshoe. And the shape symbolizes an arc. And it became a lucky symbol over time for them called a horseshoe. But this was a rope, and this symbolized the number 10. This symbolized our first binary digit. Our first non-single digit, our first binary digit, other than the new numbers you will learn up here, like 0 and 9. But that's what that represented, and it represented an arc or an angle. And it was very important. It represented a point in the mathematics where you actually turned a corner, or you actually made a turn. You turned into something. So you turned over. And so this number 0, you're going to find out in Egyptian and Sumerian, we really didn't write that number 0. We left the empty space for it, which indicated that it was a 0. But I'm going to show you some intricate things in this video pertaining to this kind of number system and in relationship to 0 and how it works. Some of the things you have to give up. Like, for instance, this number here, 10, stays 10. So I'm going to show you in the video, though. I'm going to show you in the video. We'll show it with the video, okay? But one of the things I want to show you is that this is kind of fine, 1 and 1. But when you do this, this becomes abstract. The number 2 is abstract to this. This is 2. This is the symbol for 2. This is 3. This is the symbol for 3. This is 4. This is the symbol for 4. So even though they're going to tell you that this became the superior mode of counting in mathematics, it's a certain amount of information that you lose by switching from this system, Egyptian system, to the more modern system. When you switch from this system to this system, you lose something. You lose a certain amount of information. And that's what I'm going to show you. That your children and yourself, when you count like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you're not seeing the dimensions of what's happening here like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're actually not experiencing all of the numbers and all of the information that's pertained in the numbers. It's certain things that's hidden from you.
To show 2. Similarly, 3 to show the number 3, and so on till 9. To show 2. Similarly, 3 to show the number 3, and so on till 9. They realized that using 10 rods for 10 was getting too long, so instead they used a horseshoe to represent 10. So a horseshoe represented 10. They would use 2 such horseshoe to represent 20, and so on. So 9 horseshoe would represent the number 90. Again, they realized that using 10 horseshoe to represent the number 100 would be too long. So instead, for 100, they used the symbol of a coiled rope. Egyptians made a symbol for every power of 10. They used a lotus for 1,000. For 10,000, they used a pointing finger. For a lakh, they used a tadpole. And an astonished man was used to represent 10 lakhs.
Okay, let me show you something else, family. I was trying to write it for you, as she did.
Egyptians made a symbol for every power of 10. They used a lotus for 1,000.
Okay.
symbols for every possible quantity. Then they came up with the idea of combining symbols.
Okay, now that's a tadpole, believe it or not. Oh, the app. Okay. Now, well, I'm gonna show you 100. I might as well. Okay. No, okay. Okay. One of the things I wanted to show you about this family is this right here. Is that you see one, ten, hundreds, thousand. So we actually have a comma right there. Actually, after the thousand, and then you see 10,000, and now she says a lakh. So then, instead of being um, instead of being what you'll call 100,000, she says this is 1 lakh. You notice how they have one, then the 2 zeros, then the 3 zeros, and then they have a 10, then 2 zeros, then 3 zeros. Because this is like saying 10,000,000 instead of saying a million. And this is like saying 1 lakh instead of saying 100,000. And 10,000 and 1,000 and 110 and 1. So this is the different ways in which they count. But remember, in your mathematics, you would actually not have a comma there. You actually have 100,000. In your mathematics, you would actually have a comma there. You would have it right there. It would be 1,000,000. And then where they didn't have a comma, you would have a comma, then 1,000, then 110, and the 1. Okay? So that's just one of the things I wanted to show you because that's going to come up into play when we talk about these numbers.
So instead, for 100, they used the symbol of a coiled rope. Egyptians made a symbol for every power of 10. They used a lotus for 1,000. For 10,000, they used a pointing finger. For a lakh, they used a tadpole. And an astonished man was used to represent 10 lakhs. Egyptian number system was much better and efficient than previous number systems.
Much better, much more efficient.
There were problems with this number system too. They did not have a word and symbol for every possible quantity. Then they came up with the idea of combining symbols.
Check out the white finger next to the Nubian people.
As many times as possible. So if they want to write the number 9,999, they use 9,000s, that is 9 lotus to represent 9,000, 9 coiled ropes to represent 900s, 9 horseshoe to represent 9 tens, and 9 rods to represent 9 ones. Now you can see that the problem here was that these numbers took a whole lot of space and time. So from Stone Age, we moved to the primitive civilization and then the Egyptians. All these gave way to our modern number system that uses only 10 digits. It is assumed that they too must have counted on their fingers because only 10 different symbols were used, which they called as fingers or digits, to represent 9 tens.
When she made this statement, listen.
To represent 9 ones. Now you can see that the problem here was that these numbers took a whole lot of space and time.
That these numbers here took a whole lot of space and time. See, that's one of the problems when you start trying to say space and time. That's the key. Space, time, energy, matter. That's STEM, and space-time is a continuum. So what she basically said was, due to constraints of space and time in writing, we were willing to sacrifice certain amounts of information that would be filtered into your brain. But due to saving space and time, we decided to cut that information out and found it useless. So we would just create a set of jumping genes in the DNA. We'll just cut out portions of the DNA, portions of the information, and we'll leave it with that and call it new mathematics, another mathematics.
And then the Egyptians, all these gave way to our modern number system that uses only 10 digits. It is assumed that they too must have counted.
Notice the zero at the end.
Because only 10 different symbols were used, which they called as fingers.
Zero at the end, not at the beginning.
It took a lot of toil and effort to arrive at these numbers, which
now zero at the beginning.
Familiar with these days. These modern number system came from medieval. Medieval came from Arabic. Arabic in turn came from Hindu, and the Hindu came from Brahmi. You would realize that Brahmi.
You know we gotta write that. From the modern, let's write it over here. From modern, before modern mathematics, they had medieval. Now we know medieval is nothing but the Renaissance, Europe, all of that. The Dark Ages, Bronze Age, all that, but medieval. And then we know Arabic is nothing but the Arabics. Arabs. So really we have modern European American, English, British, modern European American. Then you have medieval, which is old Italian, Spaniard, European. And then you have your Arabic, which is your Denocevan man, your caveman, your Denocevan man. And then you have your Hindu. And then you have what they call Brahmi. Brahmi. Some people may say Abrahamic or Brahmic, but no matter what the case, it's Brahmi, Hindu, Arabic, medieval, and modern. And so she admitting that all of these actually came from Egypt. We put Egypt right here. She admitting that everything here, all of these, came out of Africa. She admitting that all of this mathematics here is really Nilotic mathematics, because she tells you that Egypt is where mathematics start, and she tells you that the cavemen, they have no concept of mathematics. They only had 30 symbols that they used. But the Egyptians actually had mathematics and built structures using mathematics. So all mathematics come from Egypt, y'all. Don't forget it. You heard it straight from the horse's mouth right here. Here she go, right here.
9 horseshoe to
See?
represent
The horse's mouth.
and 9 rods to represent 9 ones. Now you can see that the problem here was that these numbers took a whole lot of space and time. So from Stone Age, we moved to the primitive civilization.
Stone Age would be the pygmies, y'all.
All these gave way to our modern number system that uses only 10 digits.
Zero at the end.
It is assumed that they too must have counted on their fingers because only 10 different symbols were used, which they called as fingers or digits. It took a lot of toil and effort to arrive at these numbers, which almost everyone is familiar with these days. These modern number system came from medieval. Medieval came from Arabic. Arabic in turn came from Hindu, and the Hindu came from Brahmi. You would realize that Brahmi had only 9 numbers. 0 was not introduced then. 0 came in much later when the Hindu script was written. So these are the 10 numbers which everyone is familiar with, which is our modern number system. So we've seen that this is a modern number system that uses 10 numbers or 10 digits. Well, using these 10 symbols, we can write any number in our modern number system. But now, since you know how we actually got these numbers, how much hard work has got into getting these 10 symbols, I hope you can appreciate the amount of hard work that has gone into these numbers. So don't take these numbers for granted. So these are the 10 numbers, and now we have seen that our modern number system has evolved from a lot of civilizations. But in a way, we can say that it is not much different from what the Egyptian number system was. Let us see. Let's take this simple addition problem in our number system, which is 342 plus 420 plus 205, which gives me 967. Now, if I look at the same problem in Egyptian number system, it would look like this.
So we could.
Pretty complicated. But yet again,
it's the same problem.
It is not much different from our number system.
Even to the day, it's the same mathematics.
If I look at the Egyptian
it all came
number
from
system
Egypt.
as groups of symbols, if I group the symbols
See
together,
that? 342.
and compare these groups of symbols with the digits of our modern number system, then you would find some similarity.
Which one looked the most fun for the children?
300s.
Which one you think you like?
Tens.
The Egyptian sure looks fun over there.
Two ones.
Sure looks like it's explaining a lot.
You'll find some similarity. Now further,
It's
if I
3,
place
it's
these
4, and
groups
it's 2.
also
3, 4, 2.
into columns of ones, tens, and hundreds. If I place it in columns of ones, tens, and hundreds, then you would see much more similarity. What is clear between these two number systems is that the Egyptian number system has no symbol for the number 0. There is no symbol here or here for the number 0. Another difference is, which is more important, that in our number system, the same number 2 is being used for ones place, in tens place, and in hundreds place. So the same number 2 here represents 2 ones. The number here is representing 2 tens, whereas here this number 2, the same symbol is representing 200. Whereas if you look at the Egyptian number system, they have different symbol for 2, a different symbol for 20, and again different symbol for 200. So importantly, what we see that in Egyptian number system, they need not place the numbers into groups or columns because there was no need of that. They had different symbols for different digits, and hence there was no need of placing it into different columns, and so 0 was not needed. But if you look at our modern number system, up to 200. Whereas if you look at the Egypt here or here, or the number 0.
Let me show you something, family.
Another difference is,
I'm gonna show you something right quick. Just from the. Well, let's do it here. Oh no, the top number is what? 3. And this number is 40. And the next number is 2. And the next number is Okay, now family, right here, well, you have in modern terms 342, and you have in Egyptian terms 342. This has more information in it. Your child not only has to look at this abstract number no more. Your child can see three things and say that's three. And then your child can see four things and say that's four. And your child can see that's two things and see that's two. And then your child can see that all of these come from a different form of numbers. That this is hundreds, that this is tens, and that this is ones. Whereas here is nothing to indicate that other than them going from this side left to right, and then me automatically knowing 340 and 2. Whereas here, I get an automatic distinction in my mind as a child all through my life growing up that this is hundreds, 300s, this is 10, 4 tens, this is ones and 2 ones. So first of all, this has more information. So write that down, more information in this. And then you say 420. This has too much information. This 0 is not really necessary. It's necessary because this looks like 42. But in Egyptian mathematics, if you have the number 100 and you have the number 10, then the only number that could follow would be 1. And since there's no ones, there's no need to put nothing there. So this tells you by having a different number category for hundreds, having a symbol for 100 and having a symbol for 10, tells you that there are no ones, so there's no need to write 0. So therefore, mathematics becomes a language, and there's no need in adding that information to the context or to the conversation because it's not necessary. There are no ones, so it's 0. And then here is 205. Now, the reason why we don't need a 0 here, 205, is because when you look at these two symbols, it automatically tells you that this is 200. So what follows 200 is 10. But there are no 10. So there's no need to write anything there. So then, 205. 1, 2, 3, 4, 5. 205. And the 0 is understood in the context of the sentence, of the mathematics. So for them to try to say that we didn't have a 0 or that we even needed a 0 is a lie. To say that we needed a 0 or didn't have a 0 when we had knowledge of 0 and found no need to even write the number 0 down because it was self-explanatory in the way in which we carried on by writing tenses of numbers. Tenses of numbers like tenses of words, ones, tens, hundreds, thousands, 10,000, 100,000, and 1 million. And by the way, this is not a man in astonishment. This is a man in the state of ma'at, because that's a feather on his head. And he's in the state of ma'at at 1 million. He's in a state of harmony. He's in a state of prayer, peace, abundance, ka, spirit. He's in a state of ma'at. And this frog, or tadpole as they call it, represents a portion of the Ogdoad. And this represents a digit of the finger, which is very important in Egyptian mathematics as well as in Egyptian knowledge. I'll leave that alone. And then the lotus is 1,000. And this spiral, this helix spiral here, that the Egyptians had knowledge of a spiral, represented 100 because it was a very important number. And this represented the bending of a rope or the bending of space-time, moving into another dimension of binary numbers and trinary and quaternary and quintupletary numbers. And this was the number 1. This was the single digit. And that's why it's there today, preserved as the number nu. Okay? So because of our number system and having a symbol for 100, whereas you do not have a symbol for 100, you only have a system that says that if it's 3 digits, then it's in the hundreds place. If it's 2 digits, it's in the tens place. If it's 1 digit, then it's in the ones place. But in Egyptian mathematics, we had an actual symbol that said, no, this is the hundreds place, this is the tens place, this is the ones place. And so if it came down to 0, then we didn't have to write 0 because it was self-explanatory in the sentence. You couldn't have 420. Where the ones? Where the ones? There's no need to ask them where the ones at. 420. That's the answer. That's exactly what it is. 420. Ain't no one. 200. Where the tens? Where the tens? There's no tens. 205. 205. That's the answer. That's how we knew it. So we knew mathematics that way, family. So it's no disadvantage in counting in Egyptian mathematics.
Which is more important, that in our number system, the same number 2 is being used for ones place, in tens place, and in hundreds place. So the same number 2 here represents 2 ones. The number here is representing 2 tens, whereas here this number 2, the same symbol is representing 200. Whereas if you look at the Egyptian number system, they have different symbol for 2, a different symbol for 20, and again different symbol for 200.
See that? See how that number becomes 20 and 200 and not 2 and 10?
Egyptian number system, they need not place the numbers into groups or columns because there was no need of that. They had different symbols for different digits, and hence there was no need of placing it into different columns, and so 0 was not needed. But if we look at our modern number system follows positional notation. What is
positional notation?
That same digit is used, and same digit represents different quantities when placed in different positions. So this number 2 is representing 2 ones also, number 2 is representing 20 also, and 200 also. And this is why the need of 0 was felt, and 0 was used to represent the column that did not contain any digits. What would you call this 2 as? Is this 2 ones? Is this 2 tens? Or is it 200? So the same digit, when I put a 0 in front of it, it becomes 20. When I put 2 zeros, it becomes 200, and so on. So importance of 0 was felt, and that's why 0 was included later. We've seen how 0 was included much later. Why was 0 included much later? Because there was a need for 0 that was felt as a symbol for columns that had no digits. So that's how our modern number system follows the positional notation. So we've seen the 10 digits which we use in our modern number system. Now there's an interesting side to it which says that how did numbers actually came about? Why was this symbol used for 1 and not any other symbol?
This is not true, family. I'm going to let y'all watch it, but this is not fact.
So you can find only one angle in this number 1, and so this number 1 came. Similarly, for 2, we have this symbol because it makes 2 angles.
Lies.
3 because of 3 angles.
Lies.
Similarly, 4 for the 4 angles.
Now in a minute it's going to get crazy. You're going to see why it's lies.
5 makes 5 angles. Again, 6 would make 6.
Right here is where it's go too far, right here.
7 angles in case of 7. For 8, I have 8 angles. And for 9, I should get 9 angles. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I get 9 angles in case of 9. That's why 9 has this shape and this symbol only, and similarly 2 has this shape and this symbol. Now, since 0 came in much later, you can well understand why 0 was shaped like this. Because if I have 0 which looks like this, then that means there are no angles. So 0 shows no angles. and 0 was called shunya. So this is a modern number system which uses 10 symbols, and we can use these 10 symbols to represent any number.
Very good video though, family. I really like that video. So basically, let me pause this. Basically what she showed is that the superiority of your Egyptian mathematics and how important it is to you to actually learn that and actually study that. Let me see right here. So next time we come through though, we'll probably watch this video called A Brief History of Numbers Numerical System. Okay? We'll check out this video called A Brief History of Numerical Systems. I say that in case anybody want to go and catch that out in advance, but it's on TED TV, and you know, it's a brief history on numerical numbers, on numerics. And so here they're gonna explain a lot of stuff about numerics.
1, 2, 3, 4, 5, 6,
okay?
7,
We'll
8,
watch that
9.
next time. But this time, on the notes that we have, which you already pretty much explained them, we'll just go back through them again. The Egyptians did not have to write the number 0 because we had a different number for each tenth or each notation of numbers. Each notation of numbers, 1, 10, 100,000, 10,000, had their own symbol. 1, 10, 100,000, 10,000, 100,000, million. Each one had their own symbol. So then there was no need to write all of these zeros. We found this to be redundant, to write all of those zeros. So instead of writing all of those zeros, we could just write that just by writing a single symbol. So at a certain point, you could say that this is more efficient than writing out the number 1 million. At a certain point, you could say this is more efficient than writing out the number 1,000, 100,000. And this is more efficient than writing out the number 10,000. Let's see. That's a finger. Let's see 10,000. Oh yeah, it's a lot easier to draw the finger. And the lotus is 1,000. The spiral versus 100. This versus 10, and this versus 1. So in all actuality, these numbers are a lot simpler to write than the other numbers. If you just look at it, and if one was to become very proficient at this, then one could just race right through this. You know, if one was very proficient at this, then one could just race right through that and be done with the numbers. So those would actually be your real numbers, is what I'm saying. That's how that would work. And so we talked about this arc equaling the angle right here. She mentioned to us even that modern, medieval, Arabic, Hindu, Brahmi all came from Egypt. And Egypt is in where? Let's say it loud. We black and we proud. Egypt is in Africa. Egypt is in Africa along the Nile River with Nilotic people. Nile River, let's make it clear. And the Nile River extends all the way into Sumer. That's right, because the Nile River becomes the Tigris and Euphrates rivers. So it goes from Sumer, from Babylon to Timbuktu. That's right, to Timbuktu. So from Babylon to Timbuktu, all the way down to Mount Kilimanjaro. So we know that these people are the supreme being. And that's why we said in the write-up that we want to return you to your higher state, to your higher frames of consciousness, your higher symbols of knowledge and information. Try to return this and remind you of what this all means, because this is not just something that was just left behind for you to transform this into that. You don't think that we as ancient Egyptians knew this? We as ancient Egyptians knew this. We knew this, but we knew that this wasn't effective. It wasn't all the information. We deliberately kept it as this for thousands of years. So we have to reintroduce this kind of system back into our children's minds in order to have full consciousness. And it will not start by you just creating, well, actually, I'm wrong. It can start by you just working alone and creating. But however, it will be more efficient and more effective for us to take something like new mathematics, mathematics that's already developed around this system and around these concepts, these axioms, these maxims, these laws, these proofs, something that's already based around this that we're already doing here in new mathematics, and allow us the opportunity to deliver the information to you in its finished form as opposed to you having to relearn it. We already have done the mathematics for you. Allow us to put that information out to you, and you purchase that information. Inquire about our number line. We're going to have the number line coming out soon, regardless if anybody supported it or not. And that's right, BASTET. Facts. So, what else? So that's about it. And this number system here, this one, and there's these rods, and he was given a rod to count the number and number the nations of people. This is that rod. This is that rod that you'll be given to count the nations of the people. And this is it. And so you have to remember that rod and that staff, they comfort me. This is the knowledge that'll comfort you. This is the Shiloh. This is the law. This is keeping the law. This is the real deal here. So by having this number system up here, it's superior than this number system down here. I repeat, having this number system up here is superior than the number system down here. So remember, this is the true way to count, okay? This is the real way to count. And by putting this in your children's mind, it holds a certain amount of information that's different than these numbers right here could ever hold. These numbers are too abstract in order to hold the information in which we try to retain. Okay? So with that being said, family, we'll close out this math session, and I'll meet y'all again on another math session. And I'll build again upon this and add some more information to it. But, math can be very long. Math can be very draining. So I'm going to stop it right there and let y'all marinate on that. Peace and love.